Good morning. This is your stats sensei, Mr. Spensei, and we're going to go over yesterday's quiz. And tomorrow's test will be similar in design. All right. So, a company is testing the effectiveness of a new social media marketing campaign at increasing online purchases of their popular energy drink among high school students. The company has an online customer base of over 1 million high school students. The company randomly assigned, that's important. So we have random assignment, over 2,000 students to one of two groups. One group of students who were exposed to the new marketing campaign, and the other group was not exposed to the new marketing campaign. The company wants to estimate the difference between the proportions of students who made online purchases of energy drink in each group. It was found that 954 students of the 1,124 students who were exposed to the marketing campaign made online purchases. All right, so this is our X1 and our N1. This group is the group that purchased and were exposed. All right. Of the randomly selected group of 1,203 students who were not exposed to the marketing campaign, it was found that 875, so there's our X2 and our N2 right here, construct a 97% confidence interval for the difference in proportions of energy drink purchases for those exposed to the marketing campaign versus those who were not exposed to the marketing campaign. All right, so as always, with a confidence interval, we have to start off by defining our parameters. This will take me a little bit of time because when we're defining our parameter in this case, we have a couple things we have to talk about. First off, we're always going to say let P1 equal the true population proportion of students who, well, which students are they? Who purchased an energy drink, or the energy drink would probably be better, the energy drink online and were exposed to the marketing campaign. This one had a whole lot. We had to have both. We had to mention that they were exposed to the campaign and they made the purchase. Let P2 equal the true population proportion of students who purchased an energy drink online who were not exposed to the campaign. And it's really to the marketing campaign, but we can shorten it up a little bit. But it's really important that you talked about that they made a purchase and they were exposed to the campaign. You had to have both of those things to receive full credit. That was probably the most missed 5 points is we didn't say that it was both of those things because they had to make a purchase and it had to be exposed to the campaign or not exposed to the campaign. All right. Next thing that got people was if this was random assignment. And that was given. And this was also random assignment, and it was given. We had random assignment of 1,124 on this one. and random assignment of 1,203 on this one. So we're going to have to check the normality condition. We have to make sure that we're large, that our sample is large enough to use the normal approximation. And it's n p hat and n times 1 minus p hat. And this is, and I need to just put a 1 in front, n1 times 1 minus p hat. This is going to be n2 times p hat 2 and n2 times 1 minus p hat 2. That's what we're going to be checking. And in this case, our n was 1,124 times 954 over 1,124, and that equals 954. I did not bring my calculator out. There we go. All right, equals 1,124 times 1 minus 954 over 1,124. And this equaled 170. Both of these are greater than or equal to 10. Make sure you have the statement. Okay to use the normal approx. Awesome. Then we come over here and we have N2. And in this case, our sample size is 1,203. All right. And so we're going to go equals 1,203 times 875 over 1,203. And that equals 875. This is 1,203 times 1 minus 875 over 1,203. And this is 328. Both of them are greater than or equal to 10. Otherwise, we can't proceed. So it's okay to use the normal approx. Right? See if that lines up a little better. Our formula, p hat 1 minus p hat 2 plus or minus z star p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. So that came right off the formula chart. Then x1 came from our problem. Our problem was our x1 is 954 over 1124. And some people started filling this part out first just because it helped them organize. And I think that's a really good idea. 1,124. Oops. 1,124. So p hat 1, and I'm just going to go ahead and turn it into a decimal. Now, I didn't have to. So as a decimal, we're just 954 divided by 1124. And so we get 0.8487. And x2 is 875 over 1,203. And just very simply as a reminder, the numerator is always going to be smaller than your denominator. So 875 divided by 1,203. And we end up getting 0.7273. Now, if you left this as a fraction, that was fine. You could have done that. I forgot to write down our confidence level. Our confidence level was 97%. You could have put in 0.97 and that would have been fine. And we need to calculate Z star. So second var's inverse norm parenthesis 1 minus 0.97, close parenthesis, divided by 2. And we're just going to always make it positive. So we end up with 2.1700. If you left off the O's, the zeros, that's fine. Now we're going to plug into the formula. So 0.8487, that's p hat 1, minus 0.7273. We're going to have to write this small because these are some big numbers. Plus or minus 2.17. And 0.8487 times 1 minus 0.8487 over 1,124. And then we have to do 0.7273 times 1 minus 0.7273 over 1,203. That took up a whole lot of writing. Most people did a good job getting that fit in there. All right, so we're going to go ahead and run the test. Stat test to proportion Z interval, which is letter B. And we have 954 divided by 1124, x2 875 divided by 1203, and we need to change this to 0.97. And we get our interval, and our interval happens to be 0.08515 and 0.1576. We only need 4 decimal places, so I really didn't need that 5 on the end. I could just 0.0851. All right. So what are we? Well, we are Reagan. I mean, we are 97% confident that the true population proportion of what? What were we supposed to find? We were supposed to find true population proportion of the differences, or true population difference of the proportions. It doesn't matter. True population proportion of the differences in what? Online energy drink purchases. And what were we subtracting? Exposed to the campaign minus not exposed lies within the interval 0.0851 and 0.1576. All right, that's probably about as short as you can make that. You needed to make sure you're talking about the true population difference in proportions, or true population proportion of the differences. Probably would have been better for me to put population, true population difference in proportion here, but either one is fine. And that'll take care of our first one. All right, so that's our confidence interval. I hope that helped. Make sure you get that all written down and turned in today. All right, so moving on to the second one. Now, admittedly, the second one had a typo. We won't have anything this tricky. Hopefully, we won't have any typos on the test tomorrow. So here we go. Tumbleweed, commonly found in the western United States, is the dried structure of certain plants that are blown by the wind. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from the soil that otherwise would go to more beneficial plants. Scientists are concerned that Kochia plants resistant to the common herbicide glyphosate has changed over time. In 2014, it says 12%. It really should just say 12 of 63. So this should be X1 and this should be N1. Randomly selected Kochia plants were resistant to glyphosate. And in 2017 is 21 of 57. So this would be X2 and N2. Randomly selected Kochia plants were resistant. Through the data, provide convincing statistical evidence at alpha equal 0.05 that there has been a change in the proportion of all Kochia plants that are resistant. Change, remembers, is not equal to, and we like to use the word difference or different, all right? So our hypothesis test, HO, well, that part's always going to be P1 equal P2. That part's easy. The HA, there was nothing about greater than or less than. It was about change. So P1 does not equal P2. Then P hat C is X1 plus X2 over N1 plus N2. And you really need to show me the work on this. And this is 12 plus, 12 plus 21. So this is 12 and this is 63. This is 21 and this is 57. So this is 33 and 63 plus 57 equals 120. And I needed to see where you plugged in. I need to see this right here. I don't have to see everything else, but I'd like to. I'd like to see this formula, and I'd like to see that, or I have to see this. And then I need to see, well, what is 33 divided by 120? So 33 divided by 120, P hat C is 0.275. All right. Now, there was some confusion yesterday, so I accepted a wide variety of things here. But this is basically in this case, there should not have been the word percent. That was the problem. It was supposed to be 12 out of 63. All right, so now we get to define our parameters, where we get to do all of our writing. So let P1 equal the true population proportion of Kochia plants that were glyphosate resistant in 2014. So it's real important that I say, what were they? The resistant in when? 2014. Let P2 equal the true population proportion of Kochia plants that were glyphosate resistant in 2017. All right, so it tells us these were randomly selected. All right, these were not randomly assigned, these were randomly selected. So we have random sample. Random sample. You don't have to have the size, but the first one was 63. That was given. The next one was the 2017 one. Random sample of 57. That's given. 2. N1 P hat 1. N1 times 1 minus P hat 1. So N1 times P hat 1, but it's not P hat, it's P hat C. All right, that's the big difference. Confidence intervals are P hat 1. Here it's P hat C. So in this case, N1 was 63 times 0.275 equals 63 times 1 minus 0.275. $17.325. Both greater than or equal to 10. I just didn't have room to write that. Okay to use a normal approx. And over here we have N2 times P hat C and N2 times 1 minus P hat C. So we have 57 times 0.275 and 57 times 1 minus 0.275. And this is 41.325 greater than or equal to 10. Okay to use a normal approx. The easy part, formula, Z equals P hat 1 minus P hat 2 over P hat C times 1 minus P hat C over N1 plus P hat C times 1 minus P hat C over N2. Next one, what is getting tiring, is 12 over 63. This is 21 over 57. 12 divided by 63. 0.1904. If you wanted to leave it as a fraction, you could. 21 divided by 57. If you want to leave that as a fraction, you can. 0.3684. Now we need to plug in. So Z equals, and we probably have to write a little bit small on this, Z equals 0.19404, excuse me, minus 0.3684. P hat C, that was 0.275. We calculated that up above. Don't forget your square root sign. 0.275, 1 minus 0.275 over N1, which was 63, plus 0.275 times 1 minus 0.275 over 57. All right, at this point, we're ready to go ahead and run this thing in a calculator. So we're going to go stat test, 2 proportion z-test, and x1 is 12, n1 is 63, x2 is 21, n2 is 57. We had a not equal symbol because we said it was different, it was changed. And we're going to ask it to calculate. Oops, be nice if I put it, there we go. So I get z equals 2.18. It happens to be negative. We need to include that. Make sure that you have the sign with it. Our p-value is 0.0292. And our alpha is 0.0500. This is less than. Our decision is to reject the HO. All right, reject HO or reject a null. All right, couple things. Let's point out on the calculator some things. So we have our p-value. Well, that was easy. We also have p hat 1, so I can check that out. Oh, my p hat 1's match. I have a p hat 2. It matches. And right here is p hat c, and p hat c is 0.275, and it also matches. Okay, so that makes sure I can check my work because it's all on the calculator. All right, so our decision, our p-value, should say our conclusion, our p-value is 0.0292. We reject the null. There is sufficient evidence at alpha equals 0.05 to suggest that the true population proportion of P1, which is glyphosate resistant cachea plants in 2014 is different than the glyphosate resistant cachea plants in 2017. But we can just put in 2017. So our p-value is 0.0292. We reject the null. There is sufficient evidence at alpha equal 0.05 to suggest that the true population proportion of glyphosate resistant cachea plants in 2014 is different than in 2017. All right, this concludes the video. I highly recommend you write this down, work this out. This does count as an exit ticket in class today, so make sure you turn that in tomorrow for your test. You can turn it in today at the end of class if you prefer. All right, hope this helps, and I will see you in class, and I hope your test goes really well tomorrow. Thank you.